In question 7, we've been given an example about a car consuming fuel. We've been given facts about 2 journeys, 2 different distances, and 2 amounts of fuel left in the car after those journeys had taken place. And we've been asked, using a linear model, to construct an equation linking the amount of fuel left in the car with d, the distance. Linear model means that the car is consuming fuel at a constant rate. So let's call that constant rate m, and this will be measured in litres per unit distance, which is kilometres. So the volume of fuel used must be equal to the rate at which it's consuming fuel, which is m, multiplied by d, the distance. Let t equal the volume of the tank. So therefore t, the volume of the tank, must be equal to the fuel used plus v, the amount of fuel left. So therefore, moving this around and making v the subject, I get the volume of fuel left must be equal to negative md plus t. So in a way, this is correct. The amount of fuel that's left must be equal to the amount of fuel which has been used, taken away from the total tank volume. And that will be your first answer. So we've got a third journey that this car is going to make. We're going to start with a full tank and we're going to continue till it's out of fuel. Find the initial volume, which is the capacity of the fuel tank of the car before it starts the journey, and the distance the car travels on this journey. So we're going to run the whole lot dry. So in the course of this, we're going to need to find the total capacity of the tank, which I've quoted as T, and the rate at which this car consumes fuel. So we can substitute both of these values of V and D in, get 2 simultaneous equations, and work out what T and M are. So equation 1 becomes V is left is 40 is equal to negative M, that we don't know, multiplied by the distance, which is 80, plus T. And our second equation, I'm going to subtract the bottom equation from the top equation. 40 minus 25 gives us 15, is equal to a negative 80, take away 200 will be a positive m multiplied by 120. The t's cancel. So therefore I get that m is equal to 15 over 120, which is equal to an eighth. And now we use this value of m back into one of the equations, the simpler equation, doesn't really matter which, I would suggest equation 1 because it looks like an easy calculation coming up here. And therefore I get 40 is equal to negative 10 plus t, and therefore t is equal to 50 litres. So we now need to find the distance this car would have gone on the journey, knowing now that the tank was 50 litres big. So V in our equation here will be 0 because there will be no fuel left. So sub V equals 0, T equals 50, and M equals 1 over 8. Therefore, that 0 is equal to negative 1 over 8 times d plus 50. And if you work that out, you get that d is equal to 400 kilometres. And that's the answer to B part 2. And then again, a rather silly question here. In fact, the car only travelled 320 kilometres on this journey. Evaluate the model in the light of the information. Well, the model has made so many assumptions about the constant rate of fuel consumption. If this journey involved the climbing of a lot of hills, for example, you will get a much lower distance because the rate of consumption of fuel will be higher. And there's a suitable sentence that will gain you the single mark on offer.